Good afternoon, dear students. I am Devendra Tiwari, Assistant Professor in EX Department, SIT Engineering College, presenting you my YouTube video lecture on the topic demand factor, load factor, and diversity factor. So we'll understand the concept of these three terms and related numerical exposure. So I'm starting my lecture to you. So please just focus on this. So first of all, we will see what is demand factor. Demand factor of an electric power station is defined as the ratio of maximum demand on the power station to its connected load. That is, demand factor equals to this MD divided by connected load. Generally, the value of demand factor is less than 1. It is because the maximum demand on power station is usually less than the connected load to the power station. So, the knowledge of demand factor is important in determining the capacity of equipment of the power move to a simple numerical depending on the this demand factor. A generating station has a connected load of 50 megawatt and maximum demand of 30 megawatt. Determine the demand factor of power station. So as per the formula, demand factor equals to maximum demand divided by connected load. So maximum demand is 30 megawatt, connected load is 50 megawatt. So the outcome is 30 divided by 50 equals to 0.6. Next slide. Load factor. The load factor of power station is defined as the ratio of average load to the maximum demand on the power station during a given period. So load factor will be given as average load divided by maximum demand. If power station is operational for suppose T hours, then load factor is given by average load multiplied by T divided by maximum demand multiplied by T, where T is the number of operating hours. So here load factor equals to total unit generated in T hours divided by maximum demand into T. Importance of load factor. The load factor can be daily load factor, monthly load factor, annual load factor if the time period T is considered in a day, month or year respectively. The load factor of power station is always less than 1. It is because the average load on the power station is smaller than the maximum demand. The load factor is very important because it is used to determine the overall cost per unit generated. That is, if the load factor of power station is higher, then the cost per unit generated will be lesser. So a simple numericals on the load factor. Suppose here maximum demand power generating plant is 2000 kilowatt. If the units number of units in kilowatt hour generated per year is 5 to the power 5 lakhs, we are we have to determine the annual load factor of plant. So the load factor of power station we easily understand the formula, which is average load divided by maximum demand. So here average load will be equals to units generated per annum divided by number of hours in a year. So 5 lakhs divided by 8760, which is the multiplication of 365 multiplied by 24. So here 557.078 kilowatt is the average load. Hence, annual load factor will be 57.078 divided by 2000 as per the formula. So it is 2.85%. Now, diversity factor. Diversity factor of power station is defined as the ratio of sum of individual maximum demands to the maximum demand on power station. So, diversity factor is given as sum of individual maximum demand divided by maximum demand on power station. The diversity factor of power station is always greater than 1. Why? Because diversity factor plays a vital role in determining the cost of generation. So here we can easily understand individual maximum demands will be greater than the maximum demand on power station. That's why it is less greater than 1. Go to the next slide. A simple numerical for this diversity factor. A diesel power plant supplies the following loads to various consumers. Domestic light 500 kilowatt, domestic power 100 kilowatt, industrial consumer 2000 kilowatt, and commercial establishments equals to 700 kilowatt. If the maximum demand on power station is 3000 kilowatt, determine the diversity factor. So as per the formula of diversity factor, which is sum of individual maximum demand divided by maximum demand on power station. So we have to find add all these loads. So here sum of individual, which is 500 plus 100 plus 2000 plus 700 divided by 3000. So it will come as 1.1. So here again this diversity factor is always greater than 1. So these are the three terms: load factor, demand factor, diversity factor, very important in power station. plays a vital role, and students should understand the concept and the numerical approach behind this. Thank you for listening this video, and we will meet in next video. Thank you.